And we are back now with 7.3, domain, vertex, and zeros. So at this point, you should know what domain is. If you do not, you need to return back to the previous lessons and look at the summaries. Okay, it should give you a very clear picture of what domain is. But if you're stuck, that's the first thing you should be doing is, well, wait, I forgot what those mean, so let's just look it up. So it says, describe a domain that is appropriate for the situation. Think about any upper or lower limits for the input, as well as whether all numbers make sense. Then describe how the graph should be modified to show the domain that makes sense. The second thing says, identify or estimate the vertex on the graph. Describe what it means. Then finally, identify or estimate the zeros of the function. Describe what it means. All right, so let's talk about the domain. Well, first of all, I need to read this. It says the area of a rectangle with a perimeter of 25 meters and a side length of x, and it gives us this function, and that's what's graphed here. So what I really care about the fact is this keyword that we're talking about, area. And that's important to me because I need to know what I'm looking at on this graph, what is being graphed here. So to me, I notice something immediately. This parabola has this below and this below the x-axis. That was not a very good line. There. So those two parts are below the x-axis. I don't like that immediately because the x-axis itself is when y is equal to 0. And what is y here? Y is our area. So how could the area be less than 0? So immediately I'm like, that's weird. That shouldn't be included in our domain. So how do I prevent that from being included in our domain? Well, I want to stop it here at 0 and here at what looks to be 12.5. So what I would say is my domain needs to be between 0 and 12.5. And you might not know exactly how you want to write that out. You can write that out with words, but I'm going to write it out with inequalities, like from our previous unit. So I'm going to say that x has to be greater than 0, or 0 has to be less than x, right? So x could be 5, x could be 10, but x can't be 15 because when x is 15, my area is negative. And we know from real life you cannot have a negative area. So it has to also be less than, x has to be also less than 12.5. So when it's asking for the domain for all of these 2 through 4, you need to look at what it's actually talking about. Is it talking about area? Is it talking about food? Is it talking about money? In certain situations, you can have negative. In other situations, you cannot. So you need to take that into account. Then vertex. The vertex of a function is the max or minimum. So here, I'm going to look at the peak. The peak is about here for me on this function. So you can take an estimate of what that would be. I'm going to say it's about 6. So if this is 5 and that's 10, this is 7.5. And it's midway between 5 and 7.5. So again, you're just making a guess. 6.25, not 6.75. 6.25. So I could plug 6.25 into this equation right here. 6.25 times 25 minus 2 times 6.25 divided by 2 and see what I get. And it is actually really close to what I said, 39, but it is 39.0625. But again, we're looking at it from the graph, so I'm fine with a rough estimate. And then finally, zeros. So let's clean some of this up. If I'm looking at the zeros are where the x-intercepts are. It is where the graph crosses or intersects the x-axis. So I have a 0 here, and I have a 0 here. This 0 is at 0, and this 0 is at 12.5. So notice that it says describe what this means in the situation. So for the vertex, what this means in this situation is that's the maximum area that you could have with this specific rectangle and the perimeter of 25 meters and a side length of x. So let's say you were trying to maximize the area given a specific perimeter. This would be it. This would be the maximum that you could, like maybe you're trying to maximize your backyard, whatever. This would be the maximum amount, 39.0625. I'm assuming square meters, says it right here, square meters. And that would be at a side length of 6.25. So the side length of 6.25 maximizes it. And what do the zeros mean? The zeros represent that so for y, remember that all of these coordinates are x, comma, y. So what that tells us is when x is 0, y is 0. And when x is 12.5, y is 12.5. No, it's not. When x is 12.5, y is 0. So what that's telling us is that at these two side lengths, y would be 0, meaning you have no area. The area would be 0. So that's why up here, if you remember back to our inequalities unit, I used less than and not less than or equal to, because we do not want x to be equal to 0, nor do we want x to be equal to 12.5, because that would result in an area of 0. All right, so now that I went over that one, I want you to do number 2, 3, 4, similarly to how I did here, describing the domain, the vertex, and the zeros. But not just talking out your reasoning of describing what it means in the situation, I do want you to also write a sentence for each one, okay? And that is 7.3.